Hi, my name is Calvin, and this is my 8th grade science experiment. So the purpose of this experiment was to see how the specific gravity of liquids are affected by the release of carbonation. So the supplies that we needed for this experiment was one piece of plywood, 4 tubes with funnels, a piece of heading for the vacuum, and then this little vacuum source, which we use. See. Alright. So the liquids we are using in this experiment are 7-Up, root beer, and Diet Coke. Not Pepsi, Diet Coke, because Pepsi is trash. And our control that we are using is water. Alright. Now for step 1. You want to fill in the tubes with the liquids, and then you want to make sure all the liquids are at this little red baseline right here. And you want to make sure the liquids are settled and they're not very bubbly. You want to make sure they're nice and settled. And see, as you can see that I'm doing, we are using this as a little eyedropper to make sure all of these are equal to the baseline. So now we are going to seal off this valve right here. We want to make sure our vacuum source is plugged in to this outlet. We're going to use this straw right here. Plug it in right there.
Very careful, you only bring it up to the test point. Close the valve as soon as it gets up there. A little more. Bring it up a little more. It's the carbonation boiling off that's taking the place of the vacuum. Oh, that's good. It'll come down to the test point.
So as you can see, the carbonation has been released a lot from the liquids. But now it's kind of settled down a bit. So what we're going to do is we're going to bring the liquids back up to the test point, and then we're going to record our before carbonation results. Alright, so this is root beer right here, which looks like 25.5 positive and negative 24. 7-Up looks like about positive 25 and negative 24.25, and Diet Coke looks like 26 positive and 24.5 negative. So it looks like right now that Diet Coke is the lightest of them all, and it's actually a little bit lighter than water. Now we're going to unplug the vacuum source, and we are going to wait 2 hours for the carbonation to wear off.
2 hours later.
Alright, so it's slightly over the 2 hours, and as you can see, the carbonation has gone away in the sodas. So what we're going to do is bring these sodas back down to the baseline to see how much they've really lost their carbonation.
Their volume?
Oh yeah, their volume. And as you can see, it has lost quite a bit of volume. So we are going to add some flat pop over here to the liquids to make sure that they're all at the baseline. So yeah, this is root beer. Alright, so we added some of the flat pop to top it off and get it all of the sodas equal at the baseline. And what we're going to do is we are going to bring it back up. So first we're going to seal off this valve, and we're going to plug in our vacuum source into the outlet. We're going to drain it up. Slowly do it with the valve all the way up to the test point. Okay. So as
You
you
can
can see,
unplug it and then let it down a little bit, buddy. You went a little too far, so you can always go down.
okay. So it looks like for root beer, it's about 24 3/4. And positive and negative 24 1/4. For 7-Up, that'll be about positive 25 and negative 24.5. And for Diet Coke, it is positive 26 again and 25 1/4 negative. So as you can see, as the carbonation has been released from the sodas, it definitely changed the amount of the volume in these liquids, and you can see the difference and how it changed the weight of the sodas. And that's my presentation. Thanks for watching.
Which is the heaviest now?
Well, the heaviest in order would probably be root beer, 7-Up, and then Diet Coke.
And how do those compare to water?
Diet Coke is a little bit less than water.
A little heavier?
Oh yeah, a little heavier. And then the other two are obviously heavier.
Yeah, root beer being the heaviest?
Yeah.
Okay. Cool. Drink some soda.